All right, guys. So this is the first section of geometry. Okay, so your screen might look a little bit different. All right, but basically you have all these different lesson things that I kind of assigned to you. Now they're not all assignments. Okay, and I know it looks like a lot, but I promise 10 to 15 minutes, and you can look through all this stuff. Honestly, probably 5 to 10 minutes. I'm going to take you through everything. And show you what it looks like. It may not be like this every time, but this first time I want to take you through everything, make sure you understand the terms and everything like that. Since we're starting off, we always start off with something, a little bit simpler, and then we build upon it as the year goes on. And also, we start off with a lot of terms, okay? A lot of terms that you're going to see that you might not just have to like get a straightforward question about this term, but we're going to use these terms as for the rest of the year. So we'll definitely be using most of these terms for the rest of the year, okay? So to start off, 1.1 explore and reason. This is something you're going to click on, okay, when we get started. And you can do this in class or at home, doesn't matter, but you need to answer these two questions, okay? Just need to answer these two questions to the best of your ability, all right? Just want to see where you're at, okay? And then this second part kind of takes you guys through some basic terms, okay? So a lot of this stuff, guys, you already know. Like the first thing is point, line, and plane is what we're going to talk about. So the first one's point. A point, it has a location, it has no size. Okay, we're talking in 2 dimensions. It has a dot next to it that denotes that it's a point. Notation. Whenever you see the word notation, it starts with N. So when I think of notation, I think of a name because name starts with N. So that's really all we're saying. Notation just means how do we name this thing? All right. So we name it with an uppercase letter. In this case, they're using P. So this is going to be point P. That's how we'd read it. Okay. Now, if we move on to the second one, it's line. Okay. So line is an infinite number of points. Now, they only give us 2 points, and you'll see why in a second, but it extends in opposite directions, all right, forever. So these two arrows, that's what that means. That means that it extends in those two directions forever. And if you notice, our notation over here, all right, it's kind of cut off at the top, but our notation, the second way we have to identify this line is we have these two arrows, okay? So those arrows tell us that, hey, it goes in both directions forever, all right? So we're using that when we draw the line, and we're also using it when we name the line as well. Now, if you notice, there's only 2 points on this line. We only use 2 points to name it. So when you are naming a line, you need exactly 2 points, and this will be something you want to put in your notebook or jot down somewhere, okay, so you have with you. Exactly 2 points to name a line. All right, so you need exactly 2 points. You don't need 3, don't need 1, don't need 4, just 2. Exactly 2. Now, there may be more points on this line. There might be other points. We call them collinear points. There might be C, D, E, whatever. It doesn't matter. You only need to pick 2, and that goes for every single time you're naming a line. Okay? So the other way we have to name a line is written above that, and it says line L. And I know that kind of looks like an E. That's what a lot of people always say, but it is actually supposed to be an L. So line L right here. And if you notice, we have this character down here next to the line. It matches up. It's another cursive L. All right, and you're always going to see it in cursive handwriting. It's going to be some cursive lowercase letter. I don't know why, just something they pick. So for this, you notice that there's no dots around L. L is not a point, okay? L is just a way to name this line, all right? It's just a character we use to name this line. So don't get confused with L and points and everything. L, you just need one label, and we call it line L. Just a little bit easier way to name the line. All right. However, if you notice, line L and line AB, they're the exact same thing. So I think about this as like someone has a nickname. All right. It's their name. We're talking about the same person, but we might use two different names to get attention to that person. So it's just like a nickname, okay? So a person may have, you might call them by their first name, you might call them by their nickname. You're still talking about the same person. Same thing, we're still talking about the same line. So a plane. A plane is an infinite number of points. So it's basically like an infinite piece of paper, like a piece of paper that goes on forever. So it's kind of hard to think about a piece of paper. So this is what I want you to do. So it's kind of hard to think about like an infinite piece of paper. The infinity is always something hard to think about. So this is what I think about. So go ahead and close your eyes. And imagine if you're on a boat, okay? If you've never been on a boat, that's okay. But imagine that you're on a boat, all right? And you're going out to sea, and you can see the shore, and and all of a sudden you get to this point out in the ocean where you can't see anything. You look in every single direction, and you just see blue water, okay? That's like what a plane is, okay? It goes on forever. So if you look one way, oh, it's going on forever, it's going on forever, it's going on forever. That's kind of what I think about when I think about a plane, okay? All right, it extends in every direction forever. So, for this one, they give us conveniently 3 points, and they call it plane X, Y, Z. So we have X, Y, and Z all have a dot next to them, their points. So we need exactly, and again, please write this down somewhere, exactly 3 points to name a line. Or to name a plane, I'm sorry. Exactly 3 points to name a plane. All right, so we have our 3 points. That's one way to name it. The other way is we have this uppercase letter, and it'll always be an uppercase letter, and we have plane M. Okay, plane M. So if you look over at the plane, it has the uppercase letter right there. However, there's no dot next to it. So again, that just tells you that it's there to be a label. Okay, some character we use. In this case, we're using an uppercase letter. When we did a line, we used a lowercase cursive letter. Okay, so for this one, it's just some label that we have to name the plane. Again, two different ways to name it based upon the information you have in the picture, and it's yours to choose if both of those are in the picture. Okay, now so that's all we have for this first part. So I'm going to close out of this. If you needed that longer, just pause the video. And then we're going to go on to the next terms, okay? So we're going to go on to the next terms. And for this, we have a bunch of different terms, but luckily, based upon what we just learned here, shouldn't be too bad. So we have a segment. All right, is just a part of a line, okay? A segment, like if you watch a segment of a movie clip, you watch part of that movie, okay? So it has two endpoints. If it's a segment, it's got to end. So it has endpoints A and B. That's how we denote it. That's how we name it, A, B. And also, if you notice, before when we had a line, we drew those two arrows because a line had two arrows. A segment just ends just like in the name. It's just a line that ends, okay? So that's how we're going to name it, with A, B. It's just like a line. We're just going to name it with exactly 2 points, not 3, not 1, not 4, not 7. Exactly 2 points every single time. All right. The next thing is array. Okay. Array has an endpoint. So in this case, the endpoint would be M. All right. And then it extends in one direction to infinity. Okay. And hopefully we're kind of noticing a pattern at this point that, hey, for any type of line, because array is just like a type of line, that we have MN, we have 2 points. All right. So anytime we're naming segments, rays, lines, whatever, we always use 2 points. And then what we draw above those 2 points is whatever the figure looks like. So in this case, we're going to draw a ray. It's something where it starts, goes in one direction. We put the arrow over there, and we're done. So that is how we denote a ray. All right. So the next thing is we're going to have opposite rays. Okay. Opposite rays, we have, if you look at this, we have this ray that starts at T and goes to S. Okay. And goes on forever. T to S. We have ray TS. We put that label above it. The next thing we have is ray TU. All right. TU. And again, we have the 2 points. We put the label above it. We're good to go. Now, if you notice, like when you see the picture originally, it just looks like a line. All right. So opposite rays, they form a line. Okay. So they have, and if you see a line with 3 points on it, pick the middle one and you can divide it into 2 separate rays. Okay, so they might ask you to do that and say, hey, here's a line. What are the 2 opposite rays that form that line? Well, pick the middle point, draw your 2 rays, okay? All right, so next we have, and lastly, and this is probably the most important one, okay? This is the one that people kind of screw up. This is the one that's going to be with us till the end of the year. This is not leaving, okay? So make sure you're paying attention for angles, okay? Angles. So angles are formed by 2 rays, and where the 2 rays meet is what we call the vertex. So the vertex of this angle is Q right there, and it's formed by ray QR and QP, okay? So that's where the 2 rays meet. Now, for naming this angle, okay, the first way that we can name it, all right, is just by saying angle Q, just by naming it by the vertex, okay? By naming it by the vertex, and that's fine. And that'll work, some of the time. However, what if this happens? If I extend that line and then I extend it down here and I put, A and B over here, so we have a bunch of different rays. All right? So now if we're looking at the picture, if I say angle Q, I could be talking about any of these angles, okay? There's 4 different angles there. I could be talking about any one of them. So you can only use angle Q if there's only one angle there. If there's more than one angle there, you cannot use that. You cannot use it at all, okay? So just be aware of that, guys. So now the next method, it's the surefire method. It's the way that is always going to work every single time. You can always name an angle this way, okay? Is angle PQR. Now, if you notice, we talked that Q is the vertex, okay? Our middle letter is the vertex. So if we're talking about naming an angle, this is what I do, okay? This is what I do. This is what I do every time. So we know the vertex is Q. We know it's going to be in the middle, but how do we name it? How does that all work out, okay? Well, we don't want to start at the vertex. What we want to do is we just want to trace this angle without picking up our finger, okay? We want to trace this angle. So what I want you to do right now is do it with me, all right, is put your finger on P, okay? Put your finger on P, on point P. So we're just tracing the angle. So if I start at P, okay, and I'm just tracing the line of the angle, I'm going to go to Q. I'm tracing the line, and then I'm going to go to R. So this is angle PQR. I'm just tracing the angle. Now, we could also name it, because some of you guys have been like, well, why do we have to start with P? You don't have to start with P, okay? So you could also name it, and again, we're still with method 2. This is the surefire way you're going to work every single time, all right? We could also name it if we started, you're like, oh, I want to start with R. All you got to do, again, put your finger on R, all right, and trace it with me. We're going to start at R. We're going to trace this angle. We're going to go down to Q. We're going to go over to P. So it's going to be RQP. And if you notice, and hopefully we got some observant students out there, that Q is in the middle, all right, because Q is the vertex. So either way we do it, Q is going to be in the middle. Okay, so if we trace our hand over that angle to name it, Q is always going to be in the middle. And then the last way to name it, this is the way we probably will use the least, all right, is just by saying sometimes they put a number in there. So they put a number in there, and for this one, they're calling it number 2. So number 2, they could put that 2 in there, and we could call it angle 2. Probably not going to use this too much, okay? So like I said, if you're looking for the surefire way to do it every single time, you are going to want this second method, all right? That'll work every single time, naming it with 3 vertices, and we're good to go, okay? All right, so that is all we have for that portion of it. So at this point, we are done with definitions. Thank goodness. All right, right? So we're moving on to like the concepts and using them to solve problems and everything. So this first one, and we always start out a little bit simple. So this seems super simple. I understand. All right, it should be. We're talking about distance on a line, measuring with centimeters, okay? And all we're saying, anytime we're talking about distance, so when I think about distance, I think about like running. I don't really like to run, but I think about running because you can run a certain distance. You can run 2, 3, 4, 7, 26, whatever miles. However, you can't run -5 miles. Doesn't matter. Some people are like, well, what if you run backward? Ho, ho, ho. Guys, if you run backwards, you just ran backwards 1, 2, 3, 4, 6, 7, 8 miles, whatever it is. Okay? So it doesn't matter. You can't run a negative distance. So that's why if we want something that can't be negative, we're going to use absolute value. Okay. So in this case, they're asking what's the distance between X and Y. All right. Now, if it's a super large distance, this one's 7 and 3. So I figure you can always just go 1, 2, 3, 4. Done. It's 4. That's fine. You can do that. All right. So if you have trouble with this, draw your number line, count, you're good to go. However, if you wanted to do it, just punch it in your calculator or something like that, you could do this. You could do 7 minus 3 or 3 minus 7. Just remember, like if you did this 3 minus 7, you are going to get the absolute value of -4. So make sure when you take the absolute value of -4, that's going to give you 4. All right, so just be careful with that. Make sure we don't have a negative distance. All right, so moving on to the next part of it. So now we're going to find the length of a segment. So in this case, they say, what is KL? What is KL? So you got to figure out what KL is. Now, if you notice they have the solution, you can click on it, but I'll work through the solution with you as well. So to find KL, you could, we're just looking for this segment right here. You could just count and go 1, 2, 3, 4. Boom, we know that the distance to KL is 4, okay? You can do that, that's fine, okay? And they might tell you K is at 12, L's at 16. How far apart are they? You could draw your number line and count. That's fine. But if we are going to use that ruler postulate, like they say, we would just do, all right, so K is at 12, so 12 minus 16, take the absolute value. When we do that, we're going to get the absolute value of -4, and that's going to give us 4. We could also do 16 minus 12, and take the absolute value. That's going to be 4, and the absolute value of 4 is 4. Good. We're good to go. So either way is fine. They have the solution here. They just did it with the ruler postulate and did the absolute value. Okay. So moving on here, we have working with a protractor now. Working with a protractor. So this is pretty basic right here. Working with a protractor. They're going to show you a protractor. They're going to show you an angle. Now, for this, if we're measuring the angle, so it kind of has this definition, okay, all right, just telling you how to use a protractor, you know, BA is at 0, BD is at 180, all right, BC is the ray that kind of forms that angle. Now, if I ask you, what is, and I'm going to put this M, stands for the measure, what is the measure of angle A, B, C, and you look on the protractor, I'll give you guys a second to think about it. what's the measure of angle ABC? So trace it with your finger, figure out we're talking about this angle right here, and that angle, just by using common sense, we should think, okay, there's 60 and there's 120. Well, it looks pretty small, so I'm going to go with 60. And if you said that, you'd be absolutely correct. Okay, so just be careful with that. The way I think about this is we all know what a right angle is. Okay, it's 90 degrees. Okay, so right angle is 90 degrees right here. Boom, right angle. All right, 90. So just think about a right angle. It's like if you put, you got your one arm that's going horizontally with the horizon, one arm that's going vertical up and down, you form a right angle. And think about, like, if I'm looking at ABC, is it going to be less than that 90? I'm going to move my arm more into my body, or I'm going to move it away. So that's kind of how I think about it. So ABC is 60 degrees. And then we have, I'm going to ask you, hey, what's the measure of angle DBC? And again, I can't say angle B because there's multiple angle B's, all right? So I have to use the 3 vertices. So this time it looks like a wide opening, looks like a big angle. So I'm going to go with a bigger number there and say it's 120 degrees, all right? All right, so moving on, doing some more protractor work here. So now we have, for this one, it says, what is the measure of angle BEC? Okay, BEC. So guys, there's a couple ways that we can do this. So just because you do it one way and somebody else does it another way doesn't mean you're wrong, okay? First, we have to locate that angle, all right? So if I just trace and go ahead and put your finger on, let's start with B, and I go from B to E to C, okay? That's going to be this angle right here. We have to figure out what that angle is. However, does B or C start at 0? Hopefully you're saying no in your head right now, because we can't just say, some of the guys would be like, oh yeah, it's 105 degrees, done. No, that angle is not 105 degrees. Okay, it doesn't look like 105 degrees, so just be careful about that, all right? So there's a couple ways that you can do this, all right? The way that I see to do it, all right, is to just figure out what the measure of AEC is, okay? So that's the whole thing, all right? That's the whole thing that we have there. That's this whole thing. And what we're going to do is we're just going to take away angle AEB, and that'll give us the angle that we want, okay? So to do this, we're going to look at the measure of angle AEC, and that is 105, all right? And then the part we don't want is this part right here, which is AEB. So the measure of angle AEB, so what we're going to do is we are going to take out that part. And if we look there, AEB looks, all right, so the measure of angle AEB is going to be 47 degrees. And I know on the picture, it kind of looks a little bit tricky because it's in between, right over here, it's in between 45 and 50. It will never be like that on like a test or quiz or anything like that. It'll always be an exact number, or else we'll give you like marks and you'll be good to go, okay? So just be aware of that. It's never going to be something. I'm never going to try and trick you like that, all right? So all we have to do now is we know the measure of the whole thing. We know what this part is. So all we have to do is do 105 is the whole thing. We were going to subtract out that 47, all right, which is the part that we don't want, to get this angle right here, BEC. So when we do 105 minus 47, we are going to get 58. So the measure of angle BEC is 58 degrees. All right. So moving on. So the next thing that I want to talk about is congruent segments and angles. So when we have these, all right, and this is where this is something very important, guys, and make sure you're paying attention and that we're going to use this for the rest of the year, okay? So congruent segments, that's where we're going to use these things called tick marks, okay? They call them tick marks. They're just a little mark on the line. So what it's telling us is AB is congruent to CD. Those marks right there, I'm just kind of highlighting them, okay? They use one mark for each segment. That just means that the length of AB is congruent, and when we use congruent, all it means is you would say, hey, this is the equal symbol, right? So that means it's equals. And then if I draw this an S and just turn it, all right, it's going to look something like this, okay? So I think of the S stands for same. So when we put the congruent symbol together, all we're saying is it's equal and it's the same, okay? So sometimes when we're talking about like triangles or figures, something like that, we're not going to really say they're equal. Numbers are equal, but you know what? Those figures are the same. They're exactly identical. So that's why we came up with this congruent symbol, okay? So moving on here. So we're saying that AB is congruent to CD. So if we're saying, hey, this is 5, guess what? This is 5 as well, okay? So we're good to go. All right, so moving on to if we use 2 tick marks, like right over here, all you have to do is you just have to match up the marks. Okay, it's kind of like a matching game. PQ has 2, RS has 2, we're good to go, okay? Now, if you look over here at the angles, it's kind of the same thing. They call them arc marks, arc marks. I like it. It rhymes, arc marks. So this one only has one mark. This has one mark. So it means those two angles, TUV, is congruent to XYZ, okay? So we have those two angles. We're saying that they're congruent. Notice how we have U is the vertex, Y is the vertex, U's in the middle, Y's in the middle, okay? Trace your finger over the angle if you need to figure that one out. Now, moving on, same thing. If we have two marks right here, then understand FGH, G is the vertex, K is the vertex, congruent to angle JKL. So we are good there because we have the two arc marks and we just got to match them up. All right, guys, that is pretty much it. We have these properties down here, reflexive, symmetric, and transitive. Don't worry about those for right now. We'll kind of come back to those later when we do proofs and everything. Just make sure you understand the congruent segments and parts. And then lastly, this is just a little, like, it's for you guys. It's just for you to look over. It has the ruler postulate, it has the protractor thing, and it shows how to solve a problem with a protractor and a ruler. So if you're struggling on the homework and need to look back, that's fine. It's here for you. So that is everything in there. Guys, obviously, if you'd have gone through it yourself, you probably could have clicked through it a little bit easier. I just want to make sure you understood it pretty well. So the last thing is the Math Excel for school practice problems and everything. That is right here. Those are some practice problems. That is going to be your homework for this section, okay? So I only think it's like 10 problems. You just need to go through and solve those 10 problems. Shouldn't take you that long, okay, guys? So if you have any questions, you can always look back on any of this information or ask a question during class or just shoot me an email and we'll figure it out together, okay? So please, I'm here to help as much as I can. All right, guys, have a good rest of your day.